Finally, section 4.4, getting to the solving part of these reverse FOILs. If you go to example 5 page, I think it's the 3rd page in. Again, you're setting it equal to 0. When you set an equation equal to 0, as long as one of your binomials is 0, you'll get a 0 output. So anything times 0 becomes 0. So there's 2 examples here we'll work on. First one is 3x squared plus 8x or plus 10x minus 8. Reverse FOIL this right away. Equal to 0. Don't forget now when you're solving, equal to 0. So 3 is 1 and 3, and 8 is 1, 8, and 2 and 4. And to get that 10, looks like I like the 2 and the 4 because then I have a 12 and a 2, and 12 minus 2 is the 10. So I'm going to try that. So 3x and x. And to get that 12, again, I need to put those 2 together. The 2 there for the 8. It's a positive 10, so I need a positive 12x. It's a negative 8, so I need a negative, and this would subtract 2 from that. So there we go. So now to solve this, take each binomial. Now you may have more than 2 eventually, but each binomial we will now multiply or set equal to 0. So it's going to be 3x minus 2 equals 0. X plus 4 equals 0. And just solve it. Solve for x. It's that simple. So I had to, we have 3x equals 2, divide by 3, and there you go, x equals 2/3. One answer. Not always so easy to check though when you got fractions, I admit. This one, subtract 4 and you're done basically. X equals negative 4. And that's easy to check. You can put that in there and see that it works. All right, the second problem, 5, 16, and 15. Oh, it equals 4p minus 5. So, okay, to solve, you got to set equal to 0. Well, it's not equal to 0. It's 0 to this mess. So I got to subtract these out from both sides, and then I'll be equal to 0. So I'm going to rewrite it over here on the side so we can look at the whole thing. So 5p squared minus 16p part 15 equals 4p minus 5. Okay, I need to get rid of these from this side and move them over here so I can just subtract the whole thing. I'll subtract 4p and I'll add 5 to both sides. Subtract 4p, add 5 to this side. Then I have 5p squared minus 20p plus 20 equals 0. Now we're ready to solve. All right, see, I can factor out 5 from all 3 terms, so I'll take the 5 out first. P squared minus 4p plus 4 equals 0. And, oh, okay. This is one of the special cases. I see perfect square, so I do 5, build my parentheses right away. It's going to be p into sign. Here's positive, so they're going to be the same. It's going to be a negative. Okay. Now, other problems we had you combine this into one binomial with a square of it. Well, I'll show you what we do. You got to set these all equal to 0. And 5, of course, 5 does not equal 0. But we just took the 5 out of this, and it wouldn't change the answer to the level of p. So this just kind of goes away anyway. And then p minus 2 equals 0, and guess what? P minus 2 equals 0. And this is kind of silly. You don't have to do it. I'm just showing you that. They're both there. You add 2, p is 2. This one's p is 2 as well. But you got to cover, right? So no worries. Okay, there's a few more examples to look at. On the next page, 19 through 21, let's try 1 or 2 of these maybe. If you can factor out, I guess, a 3 from all of those. So you have 2x squared minus x, 21. Oops, minus 21. Factors of 2 and 21. Well, I got 1, 2, 1, 21, and 3 and 7. Well, 2 times 3 is 6, 7 times 1 is 7, 6 and 7 give me that 1. So I'm kind of jonesing on these guys here. So I see a 3, my parentheses equal to 0, 2x and x, And now again, I'm liking the 3 and 7. And the 3 goes to the 2 here, again, to the outsides, right? And the 7 goes here. So I have a 6x and a 7x. Now I work out the signs. It's a negative 21, so one's positive, one's negative. I need this to be a negative. So the bigger the 7 or the 6, the bigger number 7 has to be negative. So the 7 would be this one. The 6 would be positive. And there we go. And just set them equal to 0. I'm out of room. But set this equal to 0, set that equal to 0. And that's how you do it. Have fun.